Okay, welcome back to the workshop. So as you can see, we're making good progress now. We've got all the power supply wired up. We've got power going down to the steppers. We've got the AXBB unit wired in there, or most of it's wired in anyway. So we've got the step and direction, we've got the power. At the top we've got the e-stop, and now we're starting to get some of the homes wired in. Okay, so we've made a start on the homes and limits. So they're all proximity on my machine. So all the blues will be common together there. You can see that will be the 0 volts, the brown will be the 24 volts, and then the black is the signal that comes out of each one of those. And we either want to group them together in series or parallel, depending on how we're going to implement the homes and the limits. They'll be doing it slightly different ways, but essentially that's where we've got to. Now it's taken a little bit longer because the wires weren't long enough, so each of the cables stopped about here, and then they went into a little box and it converted it from the 24 volt signal into a 5 volt that my other breakout board was happy with, which meant basically hours spent just soldering in some connections, putting some heat shrink on and running that cable back up there into the machine, and then we've got our signals coming out into the AXBB unit. Before we get into that, the other thing we looked at last time was I gave you a quick overview, well, I'll say overview, my first look at the software. I hadn't even read the manual, it was just my first look, just having a look around, seeing what I could make of it. Now since then I've downloaded the manual. It's 80 or 90 pages, so it's pretty big. I'd say I've got about a third, maybe half of the way through it, so I've still got more to go. But a couple of things caught my eye. First of all, the analog in there, it says in stroke out, so I just assumed those three were just for controlling the spindle speed into the VFD, into the inverter, and that was it. But no, only one of them does that. There's the output there, but the other two inputs allow you to connect up, say, a potentiometer. So you can use them for feed rate override or speed rate override, and there was another one you could, jog override as well. So there's a couple of different options there. So it means that my front panel, I have a, well, actually it's not a potentiometer, it's one of those little micro step type switches. Let me just show you that one. So I've got that feed rate override up there, which I've never implemented, but the idea was for that and the cycle start, hold and stop functions was to run them through a POKEYS system, and then that would emulate the keyboard, and then the keyboard would tell the software, to run each of these, like cycle start, pause and stop, and the feed rate override. However, I mean, it gets even, the more you get into this, the better this little unit becomes. So now I need to swap that out because currently one of these, I don't know if you can hear that little click, it'll just keep on going forever. It's one of those where it just gives a little step if it's going one direction or the other, and then it's also got a kind of another auxiliary function there, like a reset. So that was perfect for the POKEYS application, but really all I need for the feed rate override is just another potentiometer, which I've got in the box. So I can swap that out, and then you just run 0 to 10 and then put the output signal into the unit. So we got that. And then for the other ones, which are these, are the start, stop and feed hold, which are here. So I'm assuming all I need to do is run 24 volts into the switch, out the switch, into the unit up there, into one of the isolated inputs, and then I can control each of these, or get each of these to control the software. So basically I'll have a kind of this panel will do just about everything. It'll save me using the mouse or trying to get a touch screen, whatever. I quite like the idea of that. So, this little unit just keeps getting better and better. Whoa, hold on there. Before we get too carried away, we need to get the basics working. So that'll probably be subject of a future video. For now, we need to get it up and running. And to be honest, if I'm going to add that much functionality, I'll probably want to remake this panel completely, maybe in a solid 6mm aluminium sheet, just so I've got a little bit more real estate. And then just replace this wooden part here, so it's just a complete aluminium panel that hinges up and down, and then I've got space for a lot more switches. And if I'm going to do that, maybe I'll just change the arrangement a bit so I can make use of the extra functionality, and then I can basically control a lot more of the software. Now if I'm going to do that, if I'm going to go for it, there's a limited number of inputs on this AXBB unit, and really it would struggle to do the extra channel count. I don't think I've really got enough channels, so the obvious thing is to upgrade to the extra extension board that I think gives you 12 outputs and another 5 inputs. So let's plan it out properly. let's not get excited and carried away. Let's get the basics done first, and then we'll look into that as a potential future project. Okay, this is the proximity feed from the Y home. It's interesting how the colour scheme for these proximity sensors ended up being the same as the UK mains power supply. So 24 volt brown is same as the 240 volt live for the mains, and then the neutral or 0 volts is blue. So I don't know if that's coincidence. I'm sure they ship these proximity sensors all around the world with that colour code, unless they only send that colour code to the UK, but I doubt it. Yeah, it's just a coincidence, who knows. Oh. Okay, so that's the 2X homes there, because I've got a home on both of the X ends of the gantry. Next one's Y, so we just need to do Z next. Okay, I've come across a little bit of a problem, but I think I know what the answer is. So I've just commoned all my blues together, commoned my browns together, and then because I've got two motors on my X-axis and I want to be able to home those independently, the first pin is the first X-axis, and then the second pin is for the other X home and the Y and the Z. They all share that same pin, and it's okay to do that, because when you're homing, the software just looks for one of the pins to change state. But because I've got two axes independently homing on the X, because I've got a motor on each axis, they need to be on dedicated pins. So I've got one on channel 1, and then all the others are grouped together on channel 3. It's why you've got those little jumpers. So it was all working very well, and then I connected the Z proximity, and for some reason I was getting nonsense out of the software. I couldn't get it to it didn't seem to want to behave. I tried debouncing and everything. I think I know what the problem is. So as you can see, I've taken the front cover off there. If we have a look inside, we've got twin ball screws, one this side, that runs up from that stepper motor, one that side, and then this whole cassette, the Z-axis cassette there. If you go down, there's a big block down there that holds the main spindle in, and it runs on these 4 rails on each side. Now also in there, so you just tucked up into the corner, there's the home for the Z, and then you can see the little steel target down there, just a little disc. And at the time, obviously there's space to fit a bigger one, but I just had this one lying around, so I put that little small one in. And it is NPN, but for whatever reason it just doesn't want to play properly, so we're going to take that out and then put one of the standard longer ones in, which looks like, yeah, it will look like this. In fact, it's here. This one in, so it's, there's the number there, LJ12A3-4. I think the 4 is the 4mm sensing range, Z, and then BX. I think that means normally open, because I've got some other ones at AX and they're normally closed. And somewhere in here it'll say it's an NPN type, hopefully. Oh, there we go. NPN, which generally is a little bit easier to deal with, so I tend to go for those. So there we go, sensing range 4mm. So basically I've just taken that small one out there and just temporarily wired up this one, just to make sure it's going to work, and it's all behaving itself. So good news is I fixed it. Bad news is I've now got to take that out, take all the wiring off, which I'll trace back all the way to about here, and then it's soldered into this piece here, so I need to take that off and basically feed that through and put that one up. But at least I know it will work. I've just got a little bit of work ahead of me to do that, and then we'll bring you back when that's done. Okay, as you can see, I've got the new proximity sensor in there, so that's the new Z-axis one. It's exactly the same as all the other proximity sensors now. I think part of the reason why that little short one wasn't working is because the target down there was actually a magnet, so it's a slightly different operation, and for whatever reason it wasn't compatible, so it wasn't a good idea to daisy chain those all together. So it does make sense to use exactly the same part, and then they all seem to be compatible. Right, let me show you the wiring, and let's try some homing. So as you can see, I've just got the control unit switched on. I've got it wired in there, so the Z-axis, so we've got the X, Y and Z homes all wired together, and we've got the first X-axis is on its own channel, and then the second X-axis and the Y and the Z are all joined together on the second channel. So we're using 2 at the moment in total. And it's okay to do that because whenever you home, it only ever triggers, it looks for one trigger off one of the inputs. So in theory you could group them all to one. However, in this case I've got 2 motors and I want independent homing either end of the X-axis, so I'm actually taking up 2 channels. Right, let's give it a go. I think we'll start with the Y-axis because it's a little bit safer to home the Y. Alright, let's go and see what we've got. So in terms of the configuration of the axis setup, so we've got, as you can see, X here is on pin 1, port 2, Y is on pin 2 of port 2, as is Z, as is the X, and the B doesn't matter, it's just going to slave, it's just electronically slaved if you like, so we don't need to worry about that one. That's the second Z axis. So given we've only got 1 motor on the Y, so we'll worry about dual axis homing in a minute, and the Z, we'll come on to that in a minute. Let's just check the X is going to work. So I've got it homing pretty slow here, as you can see, 50 millimeters per minute. So let's give that a go. Okay, now the way I've got this set up, I turn this little steel disc here, that just increases the sensitivity. If you let it trigger off the aluminium, that's equally fine, but it'll just get a little bit closer because it's not quite so sensitive to that. But either work, and you can see my proximity sensor down there. I've got something that's just a little bit metal. If we just touch that, you can see the light comes on. And on the diagnostic page, that lights up on pin 2. Okay, home Y. Okay, so it's coming this way, that's fine. If it was going the other way, there's a little switch you can, a little software toggle you can make it go the other way. So in theory, if I put this here, and it's backed off, and it's stopped. Perfect. Okay, now for this one, I'm not going to put my hand in there because that'd be a little bit dangerous, but yeah, I can just trigger it like that. Okay, so we're going to home that. My hand's over the E-stop button in case. So home now. In theory. Oh, I think it worked. I was probably a bit quick there. Let's try that again. Backed off. Stopped. Okay, that works. Now this time it's put 50 in there. I'm just thinking why you might want that. Why you wouldn't want that to be 0. I guess you are backed off that home sensor. Where's the configuration for Z? Right, offset on homing 50. I'm going to set that to 0. If you let me know in the comments why that might be useful, unless you get some odd tripping. If you happen to, oh, I don't know. Well, let's see what happens. Oops. Don't do that. All right. Let's try again. Okay, this time it went to 0. Well, okay, let me know if you think it's useful to have other numbers and what you might use that for. Must admit I've always homed to 0. Right, now the more difficult one, which is the X-axis, because we've got dual axis homing. I could go and read the manual, or we can just give it a go. Now this one's potentially more exciting because I really need to kind of get something metal in both of these at about the same time, otherwise as soon as I've triggered this one it's going to back this axis off, the other axis will carry on and it's going to skew it pretty badly unless I can get in there and sort of do them almost simultaneously. I'm tempted to just put the homing rate down really low just so we don't have any incidents while we're just checking it out. So I'll just adjust that down to maybe 2 millimeters per minute, yeah, something like that, so it'll be incredibly slow, and then I can just catch it if there's anything odd happening. We're just trying to work out the principles and make sure it's going to work, and then we can turn the rates up. Right, let me go and do that now. Okay, you can probably hear that weird noise. I've got it homing at 2 millimeters a minute, which is pretty slow. I've moved the camera out of the way because the emergency stop's down here, and I'm probably just about to get to it if something bad happens. So Here we go. Let's try and do these together. Did that do it? I think I heard it change direction, and then it certainly stopped. Okay, I'm just going to run that again from a different angle. Now you can see the little lights come on, so we'll just be able to compare how synchronized they are. I say it should be pretty close because I haven't really moved this gantry since I squared it originally, and I haven't moved the proximity, so should be pretty close to each other. Right, let's home it and see what happens. That was uneventful. Okay, so we've got it set at 5mm backing off, so it should hit the sensor, and then we should see both sides come away 5mm. That way we might be able to see just how well synchronized it is. So here we go. I'll have to watch the replay, but I think, well, it certainly backed off, and see how close it was. Right, I'm going to put that back to 0 because that was just for information, but pretty happy with that. Okay, I've just got the limits wired up now, so we've got the proximity sensor there, that's at the limit for the X travel. Then on the Y axis we've got the proximity sensor there, that detects if the Y has gone too far that way and its limit, and it's got a little steel disc target down there to trigger that. Okay, so we've jogged the machine all the way down to this end, so let's test it for real. So we'll just turn the jog rate down a little bit, and here we go. Okay, as you can see the resets come on, and I can't move the machine. If I hover over these, nothing happens. So at this point we have to override the limits. Now we have to be very careful because I was just doing some experimentation, and oh, let me do a reset, don't we? There we go. Right, so that's flashing. I thought it might make a bit of a sound actually, just to remind you're in override, but it doesn't. I know some people will do that in hardware, and that is a good idea. Now, it might allow you to carry on into that sensor. In fact, let's just turn this down, let's see if it does. Yes, it will. So you've got to be very careful which way you go. Okay, now we're out of that condition. Turn the feed rate up a bit. Okay, nice. Now it looks like when you're in that override condition, it jogs at the full normal speed. Now I think Mac had a setting for that, so it jogged very slowly, and then when you're outside that range then it would go to the normal speed. There might be something in the software on that, I don't know, but hopefully I don't run into the limits too often. Okay, that's X, let's go and check Y. We've got the same thing again, so it's gone into reset, so if we override that, come out and then carefully feed the other way. Good, so limits work. Okay, so we've got everything working now, so we've got all our homes and limits. Now off camera I did check that when you go up in Z and the home is then used as a limit, that works, and when you move backwards in X, the home that's used on that side is a limit, and that also works, so we won't show that on camera. Okay, before we leave that subject, it's worth just talking about the debounce. Now when I had that originally on 0 milliseconds because I was kind of hoping that I'd got everything as clean as possible and I wouldn't need to use that, but on the diagnostics you could see every 10-15 seconds there might be a tiny little flicker on one of the limits or the homes when nothing was happening, and of course if the machine's moving around and it sees that, it just stops it straight away. So I think with these optocouplers on this device being extremely fast, the tiniest little, briefest little pulse, a little bit of noise in any of the signals was causing those to trip. So I was having to, I had to go into here, and I just wound this up to about 10 milliseconds, and I've had no issues since. So good to know on your machines, on your devices you've built, what milliseconds you've had to go to there. You know, and if my 10's particularly high, then I'm going to have to investigate filtering some of the power supplies or something like that. I've got a scope, so maybe I can have a little look around and see where the worst of the noises coming in. I'm pretty sure it's in the cables rather than RF, but you know, who knows. So let me know what settings have worked for you and what might be considered a reasonable level. Now you might notice I'm using the original version. There's a new version out, and it's got software fixes and other bits and pieces in it. I think the functionality remains largely the same, but there may be some enhancements, I'm not sure. The big change you'll notice in the new version is they've changed the screen set. Good news is you can go back to this older style screen, so you can choose which you have, but you're still running the new version. Okay, let's have a quick show of hands. Raise your hand if you like this screen set. 1, 2, 3, 4, 5. Okay, hands down, and raise your hand if you like this screen set. Oh, sorry. Okay, put your hands down. Yeah, you in the back. Okay, and raise your hand if you like this screen set. Okay, I think that pretty much decides it. If you're over 40, I think you like this screen set, and if you're under 40, you probably like this one. Good news is you get to choose, but the underlying software is exactly the same. Well, that pretty much wraps it up for this video, and for this video little mini series really. Yeah, it's all working. We've got the homes working, limits working, got all the drives working, steppers, everything's working great. Really pleased. Okay, I think it's time to summarize the software and the AXBB unit that's in there. And I think in summary, it's pretty hard to recommend. Hard to recommend if you enjoy fiddling about endlessly, tearing your hair out, you know, playing around with boards like this. I got another one that was dead on arrival. You know, the one with the blue relays on it. I'm sure you've seen the one. If you enjoy fiddling around, tearing your hair out, getting limited by step rate and smoothness and all sorts of stuff like that, you know, 50-50 on whether it's going to work or not, then don't buy this software and don't buy this unit. However, if you don't enjoy all that messing about, by all means give this a try. The UCCNC software, it's been very intuitive, no issues with it, it's very self-explanatory most of the time, and it seems to have plenty of options and configuration as well. And along with that, we've got the AXBB unit. That's been fantastic. You can see why that's such a popular device. Perfect if you've got a 3 or 4 axis machine. Now I've got a 5 axis machine, but I've got a special case where I'm twinning 2 of those together. You've got a reasonable amount of inputs and outputs. You know, if you want to go crazy on that, you'd have to expand it or go for the UC300. But for what it is and for what you need and for the price, really impressed. Very good. Okay, I think we'll finish the video there, and indeed this little video series on getting the Ethernet upgrade sorted out. I think there's more to be done with customizing the control panel and having a lot more functionality, but for now it's working, so I think we should get back to, what was it I was doing? Oh, the XY table. So hope you enjoyed, and see you next time. do it. I think I heard it change direction, and it certainly stopped. Excuse me. Okay, now I need to set up the limit sensor.